All right, enough of that. So how's everyone doing tonight? It's like we're gonna learn about useful stuff and fun stuff. We'll start with the fun stuff. Dessert first, right? So as Dylan said, this is my talk, Tracking Aircraft with Redis and Software-Defined Radio. My name is Royse. I'm a developer advocate at Redis. If you're, just out of curiosity, is anyone here an amateur radio operator? Okay, so I was going to say, I'm not an expert, but now I'm not. Totally an expert now. So if you are, down there is my call sign, Kilo Echo 8, Victor India Yankee. It sounds so much cooler when you say it that way, right? But yeah, this is my information. There's my Twitter, X formerly known as Twitter, as everyone's calling it now. The only thing on the slide that really matters to all of you here is right here is a URL to github.com/GuyRoyce, and I have all the cool code that I'm going to play with out there for you to play with and download yourself. So my goals in this talk are really twofold. So I'm a developer advocate at Redis, and so I do have an agenda, which is I want you to use more Redis, but more specifically, I just want everyone to know that Redis has event streams, and so I'm going to talk about event streams in this talk. And mostly, I'm going to talk about software-defined radio, and so hopefully you'll go with two things. One, software-defined radio is awesome, and I want to buy one. Amazon link, and no, just kidding. And two, I didn't know Redis had streams. I'm going to go check them out. But those are my two things I'm hoping you all get out of this. So, just to set the levels here, I am not an expert. I've been at Redis a few years. I could probably say I'm an expert at Redis, but I hate that word because it says everything and it doesn't say anything at all. It's like, well, you're an expert. You should know everything. I'm like, really? Everything? That's a high bar. So I'm not an expert, but I'm also not an expert at radio. Radio is a big, deep topic. There's a lot to it. I'm learning. I know more now than I wanted to do at this talk, but there's still a ton to learn. So I'm not an expert, so I might tell you something wrong. What I really do is I get excited about things, and then I make a talk, and then I tell everyone about it. And this is what this talk is. This is a demo-heavy talk, because I just basically brought a bunch of toys through customs, and we're going to play with them. I don't have one toy with me for two reasons. One, I have a little handheld radio, it's a little cheap $25 Baofeng that I got on Amazon. And I cannot use it because I'm not licensed to use it in the UK. My license class in the US won't let me use it here. But I also forgot my charger. But there's going to be a lot of demos anyhow. And this talk's going to be a little bit all over the place because I'm going to be touching on a lot of topics. I'm going to be talking about radio, the types of information, specifically data that you can pick up that's being broadcast and transmitted all over the place all the time that you can pick up without it's been there, you don't even know it's there. I'm going to be talking about aircraft a little bit and the types of signals that aircraft emit. I'm going to be talking about event streams in Redis. I'm going to show you how they work. I'll probably be a little brief on that, but I need to make sure I do enough of it that my boss is happy. And of course, I'm going to be talking about Redis some too. So the first big question that you have to ask yourself, you're probably wondering, is what the heck is software-defined radio? Well, in simple terms, it's a radio that you plug into your computer. I've got one right here. I've got actually several of them. So here, this one is very similar to one you see on screen, right? It's got on one end, it's got an antenna port. On the other end, it's got a USB port. And you hook the antenna to an antenna and you plug the USB to your computer. And if you're doing like I do and take it to customs, you need to make sure you have proper labeling. Works every time. 60% of the time it works every time. So it's a radio you plug in your computer, and so it pulls raw signals from the air and just sends them unmolested into your computer, and then your computer does all the work. It's a regular radio, but with less stuff. So if you look at these two radios here, these are both amateur radios. On the left, you've got a Kenwood HF receiver. Actually, it looks like it might be like a shack in a box and it just does everything. That radio is about $1,300. It'll transmit, it will receive, you'll listen to, you can power this thing with 100 watts and talk to anyone in the world. And this here on the right, this little radio here, is a $25 Baofeng that I bought off of Amazon. It will only talk in your local area, the 2 meter band and the 70 centimeter band, which is basically line of sight, so it gets to rise and maybe a little bit past. But both of these radios here have a bunch of circuitry in them that's there to do all the decoding and demodulating the data. So you tune things and you amplify, and all those are in there. And the software-defined radio has a tuner. You set it on a frequency. But then these radios have circuitry to like turn the transmission from a single sideband encoding or AM or FM encoding to audio that you can listen to, or to take the Morse code signals being received and turning it into something you can hear. It has a lot of extra pieces, parts to do that, and that adds cost. And so what a software-defined radio does is it's a radio but without all that stuff, and then software picks up the slack. And so the radio is able to be very cheap, and then you can download lots of free software on the internet that will let you then do all sorts of things. You can just listen to the audio. In some ways, this is sort of like an FM receiver with extra steps. But because it's cutting your computer, you can also pull the data off of it. And so rather than try to explain what it is, it's actually just easier to show what it is. So we're gonna do our first demo here. Okay, so I have plugged into here my software-defined radio. I'm using this antenna right here. This antenna is optimized for 2 meter and 70 centimeters, so that'd be VHF and UHF. But we'll pick up stuff around it, so I can use this to pick up FM radio stations. Is there an FM radio station I should pick up that's local? Preferably one that doesn't play music, because Dylan is recording this.
Yeah, hang on, let me get you the frequency.
Okay, so I've got this turned on here. So this is a piece of software called SDR Sharp. I love it because it's very full featured, its learning curve is steep. I hate it because its font is super tiny and I can't resize it on my Mac.
97.3 megahertz FM.
97.3 megahertz. So if I go to 0973, you can see a signal, can't you? Let's pull that out a bit. There we go. So we are receiving that talk radio station right now. It's streaming down there. We can see it in the waterfall display. If I bring up a decoder, and I go to, this is the thing that's always funny. It's like I said, the font's small, you can't read any of that. I can't either. And you think about your typical like ham radio operator, what do you think of? Someone that looks old, right? you think for a hobby for old men, you'd think they'd use a bigger font. So let's go to broadcast FM demodulator there, hit apply, and then close there. And then I'm hearing audio, but you're probably not.
Grappling with the news as it comes out, as more and more bodies are being identified.
What happened? Sorry. I guess I should have expected this from talk radio, honestly, so it's very unfortunate. But the point is that I'm able to tune into an FM radio station in here. This particular thing will do lots of frequencies that you can listen to. You can listen to. You can decode a lot of things with this. My favorite thing to decode with this, well, maybe not my favorite thing, but the most egregious thing that you can decode with this, in the US at least, is remember the text pagers that you used to have, to get substances? Those are broadcast in the clear. You know who still carries those all the time? Doctors. And so in the US, we can measure the number of pages that go out that you can decode and look at in clear in HIPAA violations per second. It's actually quite terrible. But there's all these signals out there. But yeah, this is in a nutshell what software-defined radio is. I'm going to go ahead and stop this here for now. And go back to my slides here. I'm going to talk about some of the things we can pick up with software-defined radio, and then I have a really cool demo that picks up really neat stuff. So, if you think this sounds interesting and you want to get the hardware, it's pretty accessible. This dongle right here, I got it for $25 US. I think they're about $30 US now, so you can probably pick it up for 25 quid. It wouldn't be a problem. That'd be my guess. I just bought it on Amazon. This kit here is a little bit more. It includes some antennas to work with, so you can do some talk. You can pick up different signals other than just the FM radio. And that's a good place to start if you're curious with this. what you'll start to do is you'll start saying, well, there's certain signals that I want to listen that are lower frequency. These are where they get fun. Because the low frequency signals are the ones that bounce off the ionosphere. And so I have this antenna right here, which I bought for I think about $30. They're about $50 now. And I set this in my living room or in my dining room and just lean it against the window. And this combined with this up converter right here, which I actually physically have right here. I'll explain what this does in a minute. But combined with this, I was able to pick up a commercial shortwave radio station from Lhasa, Tibet in Columbus, Ohio. It's literally the other side of the world. That's pretty cool, right? And so, but to do that, you need a better antenna. You can make your own. My first antenna was literally just a piece of bell wire that I had soldered to a connector, and I strung out the window through little holes in the screen. And it was just laying in my backyard about 30 feet of it. And I was able to pick up shortwave radio stations, hundreds and hundreds and hundreds of miles away. I was able to pick up shortwave radio stations out of Cuba. In the US, that's always entertaining. And amateur radio operators throughout the eastern United States, all for a homemade antenna and $25 in free software. So if you're interested, in hindsight, I probably would get right there. I would get that antenna, and then get this kit here, because this kit right here includes a software-defined radio, and it includes the up converter. So this software-defined radio right here, it can pick up the HF stuff, but it's a hack. Like you put it in a particular mode, and it's really noisy, and so it doesn't pick up anything. Your signal quality is noisy. What this does is it's designed to pick up the lower frequency stuff, and then it converts it to a higher frequency, up converts, so that then this thing can pick it up cleanly, and so that gives you a cleaner signal. So these together make a good combination. And this kit right here is got everything you need. So I think I paid about $100 US for that kit. So, like any hobby, it starts out cheap, right? And I have since bought, I got a bonus from work, so I splurged and bought myself a $1,300 radio. And then I told my wife. Yeah. Well, she's like, I'm spending the rest of it. And I set it up and I bought an antenna to go with it. And my first contact I made using a digital mode was someone in Romania. So, a lot of fun. It's just you can just connect, and there's no internet. It just all goes over the air. So cool. So this is some of the hardware you would want to look at. Software. There's several software packages out there. This is a very popular one. It's called SDR#. You can probably guess what language it's written in. I don't think it uses .NET 8 actually, but it's really popular. Obviously, it only runs on Windows, unlike .NET 8. I'm trying to help you out here. But it's a little fiddly. All this stuff is a little fiddly because it's software written by fans, and so you know how we developers are legendary at our UX capabilities. And so a lot of the software reflects that. But SDR# is a fine piece of software. It's got a huge plugin library, so you can do all sorts of decoding and stuff like that. It's a good place to start. If you want to do something small and tight, GQRX will run on a Raspberry Pi just fine. It runs on Linux, and so you can run it on very, very small machines. It's basic, but it gets the job done. Cubic SDR was the first one I used on my Mac. It's a little more advanced than GQRX. It still feels a little more basic than SDR#, but if you have a Mac, it's a good place to start. But the one that I use and the one I demoed with is SDR Angel. SDR Angel is probably the one, I don't know if I'd recommend it or not. It depends on what you want to do. But SDR Angel has a lot of things built into it. It will automatically decode things for you. SDR#, you have to install plugins to decode certain types of images and certain types of data and stuff to be broadcast. SDR Angel has all of them built in, and so you don't have to do anything. You can just use that one piece of software. And there's a lot of data out there that you can decode. We did text, or we did voice. We heard tragic news. But there's lots of data being broadcast out there that you can pick People are still using Morse code, hardly. It's arguable that Morse code isn't actually data because it's hand-keyed, and so it's more akin to handwriting. And so actually using software to decode it is kind of a hard problem, in the same way that handwriting decoding is a hard problem, which is it's not a super hard problem, but there's a lot more money being put into decoding handwriting than there is Morse code for a bunch of handwriting operators. But it's out there and you can listen to it, and people will generate Morse code from machine, and then that is easy to decode. So you can pick up Morse code and decode it. There's an old standard called RIDI that's still popular. RIDI is radio teletype. And this is how way back in the day, reporters in the field, someone would write something and you need to send this, like the newspaper article, across the Atlantic. They would use RIDI and bounce it off the atmosphere. You could pick it up here in London, and then head Dateline 1932 or something like that. And so radio teletype is still a thing. There's a lot of hams do it, so you can pick that up and intercept it. And that actually is a data format. You've got a more modern one, APRS. APRS is really neat, and I'm going to talk about it in greater detail. APRS is the Automated Packet Reporting System, but really it's a backronym because the guy who created this standard wanted to make sure the letters from his call sign were in the acronym, and so this is what he came up with. APRS is an extension of packet radio. Packet radio is a way of basically doing over the radio what you would do with a 1200 baud modem back in the 80s. And it actually uses the same protocol and encodes that same sort of noise over an FM radio signal. And it uses a protocol to establish actually an IP connection instead of X25. Anyone remember X25? There's probably a few old people that know what I'm talking about, right? Yeah. APRS and packet radio uses AX25 for amateur X25. And it's the same basic standard, but your MAC address is replaced with your call sign, because that immediately identifies you. Nothing is encrypted. But it's just kind of using the airwaves as a giant Ethernet. APRS has simplified that, and they've gotten rid of some of the connection and basically like trying to put other layers over top of the network. And it's just sort of random bursts of information that are broadcast. And people will broadcast all sorts of things. For example, people will drive around in their vehicles with the radio on and announce their location periodically, so you can then track where they're driving. I don't know why people want to be tracked when they're driving, but some people want to do it. I don't know. There are lots of weather stations that people will put on top of their houses and their businesses, and they will broadcast the temperature and the humidity and the precipitation and all that over APRS. So every 20 minutes, the weather station nearby might produce this information. Individuals can generate packets as well. These packets often usually they don't have to have location in them. So like in the case of the vehicle or the weather station, it usually has a latitude and longitude. But individuals can use their radio and they can include their latitude and longitude if they want. But they can also just send messages. So I can just send a message in this format and announce it out or address it to a particular call sign. And then when these get broadcast out, they can be picked up by other individuals. So I can listen and hear where those vehicles are at, or I can hear the weather station give me a weather report every 20 minutes. Or I can hear Dylan, who is surely soon going to get his ham radio license, right?
I just did the Amazon order now because I want that. Give me the choice. I want the choice.
I could send a message addressing his call sign, and he could hear it, and then he could respond back, and we could just. It's like text messaging with extra steps.
I love that you think I reply to stuff.
Yeah. You're just going to get the software because then by definition you can't reply. Now that's a question that comes up. This popped in my head, but it often comes up about the legality of using these. I know in the U.S., which is the only place I have any solid knowledge, that it's always legal to receive. However, sort of the rule of thumb is if the conversation is intended to be private, you're not allowed to share it. So like in the case of all the text messages that are going by that you can decode, you can look at them, but you can't share them.
So bizarrely, the UK is one of the few countries in the world where receiving radio signals can actually be against the law.
There are two cases I know of.
Television receivers are licensed in this country, and if you watch BBC TV or watch any broadcast television through the FM band without a license, you're a very bad person, and you're literally stealing from the BBC.
There's another one, is that aircraft will communicate using AM around 130 megahertz, and it's in the clear, and you can easily listen to them, but it's not legal to listen to them here. In the US, I'm actually allowed to listen to police scanners, which is good fun. That's a lot of fun. But yeah, so a little tangent there. But so individuals can pick up these APRS packets. Repeaters can pick them up. So this is where they really get useful. Because like I'll have a little handheld radio, it's like 5 watts. Realistically, it's going to get 6 miles under ideal conditions. Because beyond that, it's sort of a horizon, I can't get very far. But a repeater is just another radio on a tower that's listening, and it will listen on the frequency and then broadcast it out on a different frequency that everyone's listening on. And so repeaters will pick up the APRS signals and then broadcast them back out a moment later. And then you can put encoding in your messages saying, do 3 hops and no more. And then it'll like decrement a counter in the routing information. So it doesn't just repeat forever and just go around the earth. And many of these repeaters are also internet gateways. And this is where APRS gets really neat. Because there's a internet side to APRS where all the packets are picked up and routed into the internet. And so that means that you can send messages from your radio to services on the internet. Like there's a WhatsApp integration that will let you WhatsApp someone from your radio. And they can reply and it goes back to you. Which is kind of neat. There's a weather bot. And if you address a message to WXBot and give it a place, it will give you the weather report for that area. And so there's this gateway. And not only is it softer, but it'll actually route in and back out. So if I'm back home in Columbus, Ohio, and Dylan's over here in the UK, and I want to send a message to him, I can send it, address it to him, and a gateway will pick it up, and the network will figure out if it knows where Dylan's at, because Dylan had done something recently, and it will route it to him in a place he can hear it. So you can actually route it through and back out the internet. So it's really cool, right? It's very popular right now. These are the frequencies that they use across the globe. Here in this region is 144.8 megahertz. And there's a website that will aggregate all of this. And so you can go to APRS.fi. I don't think it's actually in Finland, but it has a Finnish domain name. And this is Columbus, Ohio here. And these are just all the little things that show up on the map here. So that's a really cool data format that is used with a ham radio and you can listen to on a software-defined radio. There's also AIS. AIS is the automated identification system used by watercraft. So any ships at sea or in river systems will broadcast data about themselves saying, this is my location, this is my heading, this is my speed, those sorts of things. And you can pick that up. It gives position, heading, speed at these frequencies. And actually this antenna here is good at picking these up. I'm not going to demo it because I don't want to take the time, and it's always a little dodgy, and I'm not sure how much. I'll probably pick up the tour boats that are on the Thames, and that'll probably be about it. But I did this in Antwerp one time, and that was fun. There's a lot of boats there. Speaking of pagers and substances. And there is a site for this as well that aggregates its content. There's actually a lot of satellites that are listening for the transponders on the aircraft or on the watercraft. And so you can go to sites like Vessel Finder or Marine Traffic and see all the traffic. Even if there's no antennas nearby on the ground, because the ground's nowhere near to be found, there's ones in the sky that are picking it up. And so here is a picture, screenshot of Vessel Finder of the Great Lakes, which is near where I live. And if we look here, you can see there's a lot of traffic right there on the St. Lawrence Seaway. You can also see the rivers. That's the Ohio River down there. And here on the left, you can see the Mississippi River, because there's boat traffic on it. So, kind of neat. I'm going to skip the demo on this one. So, but the star of the show tonight, the one I really want to show off is ADB-S. I'm going to mention some other ones that are fun to decode, by the way. There's other interesting data other than ADB-S. One of the things you can pick up. So, do you have a car that tells you when your tire's flat? You know how it does that? Well, it can't be a wire from inside your tire because it's moving. There's a little radio in there, and it broadcasts on a frequency, and you can pick it up, and you can pick up everyone else's too. And so as cars drive by, you can get tire pressure sensor reports of people's tires. Well, is that useful? No. Is it
Could
fun?
you fingerprint vehicles based on their tire pressure?
You might be able to. I'm not positive about that.
Now it's fun.
Yeah, well, because I remember when Volkswagen, I think it was Volkswagen first came out with the tire pressure sensors, if the same model were parked next to each other and one of them had a low tire, both indicators would go off. And they fixed that problem somehow, and it's probably like how Dylan said. So I haven't experimented with that. The other interesting thing I was able to do is I was able to read my water meter and my gas meter and my electric meter in my house and all of my neighbors. So it used to be the meter guy would come around and he'd come to your backyard and read the meter and write it down. And then they stopped doing that one day, and I'm like, how'd they do that? Well, there's a little radio that broadcasts my meter reading every minute. He just drives around in a truck and picks up all the signals and sends it back. And so you can read those as well. So you can build like a house energy consumption dashboard using a software-defined radio and see how much power you're using, how much water you're using, and how much natural gas you're using. Yeah?
Could you overload the radio network and then broadcast a very low consumption of electricity?
I think if you wanted to go to jail, that would be a great plan. Probably, you could jam that, certainly, yeah. I think a fun hack that you could do once would be my garage door opener.
Yes.
I open it up, and it's got like just 10 little jumpers in there, which means the code that uniquely identifies my garage is 10-bit, which means that's 1,024 combinations, which means I can tear through those really quickly. I can write software actually someone did this with a Raspberry Pi where they would use the little, like the lead on the Raspberry Pi as an antenna to transmit. They would send a signal just right from open a garage door. But I think it'd be more fun to do like a really powerful signal and just run through all, and just open up all the garage doors in your neighborhood. I think you can do that once. But it'd be a great prank. So there's lots of neat data out there to check out, and it's all you can get it with this little device. It's this little device is what ultimately led to me becoming a hand radio operator. So you've been warned. So ADSB is the Automatic Dependent Surveillance Broadcast. Again, another acronym that doesn't make a lot of sense. But what it is it's what aircrafts broadcast. It's kind of analogous to the watercraft would broadcast their location, their heading, that sort of stuff. The aircraft do this all the time too. They will broadcast continuously, hundreds of messages a second on 1,090 megahertz, the following information. Their ICOA ID, I can't remember what ICOA is, it's like International Civil Aviation Organization, I can't remember what it stands for. But it's a unique international organization that assigns IDs to aircraft. So these are always 3 or 6-digit hexadecimal numbers. And then there is actually information encoded in this number. So if the first hex digit is an A, it's American. If it's C, it's Canadian. And then there's a bunch of other rules that I don't know, but those ones are easy. And they're also the ones I see all the time. This particular ICOA ID belongs to Elon Musk because reasons. They broadcast their call sign. So if they're like a private aircraft or like a hobby pilot or something like that, this will usually be a call sign assigned to them that they use over the radio. If they are a commercial flight, it usually will be their flight number. So you see like, Ryanair 1234 or something like that. They broadcast their altitude in feet. It's in feet, that's the international standard. We are always cruising at 30,000 feet. They tell me that everywhere. That's just what they use in aviation. Their speed in knots. I still don't know exactly what a knot is, but it's a unit of measure.
It's 1 nautical mile per hour.
Right. Well, I know that.
A nautical mile is 1 second of arc,
okay.
Which has the question that a plane doing 20 knots is going tiny bit faster than a ship doing 20 knots, because a second of arc gets bigger the further you get from the center of the Earth.
See, this is why we keep doing
today you learned.
That's probably fair speed, not the ground one.
The speed is, yes, it's airspeed. I'm not positive. I have to look. I know the lat heading and the location. The location is relative to the ground, but I'm not sure if the speed is the airspeed or if it's
They
actually.
usually measure airspeeds.
Yeah.
One equals to one to the aircraft.
So, but saying, regardless, it's got one of those two there. You could very well be right. I'm just not sure. Your heading, of course, in degrees, and your location in latitude and longitude. And all this is being broadcast all the time. And I've got a piece of software which, actually, through great coincidence, was written by the guy who created Redis, Salvatore Sanfilippo. Filippo or Felipe, I can't remember which it is. I never met him. He doesn't work there anymore. Spent a Christmas weekend writing this piece of software rather than relating to his family. And what it does is it will talk to the software-defined radio using a bunch of DLLs, or if you're on Windows, if you're not on Windows, other libraries that expose the functions there. And he built a nice little dashboard. And so you can see here, you've got all this information it said. Occasionally, you'll pick up interesting aircraft. I happened, when I grabbed this screenshot, to pick up this guy right here, Jet 55. Whenever I see something like that, it's almost always U.S. military. I was actually playing around with my this radio in Poland, and I saw one that said Duke 77, and I'm like, that's got to be a U.S. military aircraft. And it turned out it was. It was doing something over there for some reason, I don't know. But so you can pick up things, like if you ever go to FlightAware or something like that, and there's some flights that you can't see, well, this sees them, because they're announcing their location. And so here we got like in this list here, we've got a United Airlines flight. There's a UAL, United Airlines Flight 296, right? But yeah, the guys who are the pilots in the military, they just have a call sign. It's just whatever they want it to be. And so it's like, yeah, I'm Duke 55. That kind of stuff. So it's all out there. And so I'm going to attempt to make this work with a demo. So let's try that. So I'm going to go ahead and shut this down. With SDR Angel. The SDR doesn't like to be used by more than one device program at a time, so I got to make sure I shut that down before I take the next one. Let's bring up the terminal here, and let's hook up the correct antenna. So the antenna I was using for the FM broadcast was one antenna, but I have this antenna here, which is specifically built for picking up ADB-S transmissions. I actually have two of these antennas. One is mounted to my house on a 25-foot mast, and the other one is in my hand right here. And now it's in a pleasant place. Okay, let's hook this up here. And I'll just lay this, I'm just gonna lay this back here for now. And we'll go ahead and maximize this, embiggen that so you all can read it. Is that big? Is that readable?
Can you crank it a little more?
Actually, I'm gonna do something better than that. I am going to change the background color so it's white. New window, that color. And I'll make it bigger. Probably is big enough for everyone.
That good at the back?
Yeah.
Cool.
The person
All right.
with the worst eyes in the back, can you see this? Okay, so change directory to my radio folder. By the way, I gave a talk the other day and someone said, you have two folders on your desktop, stuff and ham. the ham is where all my ham radio stuff goes and the stuff is where everything else goes. But if you didn't know I was in the radio, it wouldn't make any sense. So, kind of funny. Stuff and ham. So let's go to the radio folder, we're going to dump 1090, and then we'll do /dump 1090 --net --interactive. -net opens up some ports where it will spit out over a socket all the aircraft it's receiving. Interactive will just gives us a cool display look at. We'll see if we can pick anything out here. Oh wow, picked up a lot of stuff right off the bat. Now this is antenna, the antenna points down off their belly. And so I've got this antenna laying down. So this is not optimal. So if I pick it up, we should see the numbers spike dramatically. So we're getting quite a few aircraft. This is nice. I was very concerned. You never know what you're going to get. So probably some airlines that I don't know that you might recognize. I don't know what DIMFE. That's probably, my guess is that's probably a police helicopter, but I have no idea. I don't know what the conventions are around here. But we're picking up all kinds of aircraft. So I'm going to set this back down, unless someone wants to hold it vertically for me. Who wants to be the Statue of Liberty? We'll lay it down. We're getting plenty of signals for now. So I'm going to open up another tab here. Oh, come on. That was supposed to be shell, new window, this color. Okay, so we can see that we're picking up aircraft still. So this program spits out on the port, 30,002, spits out the messages in hex as they receive. They come in. So these are all the transponder messages that I'm receiving off that antenna. If I pick the antenna up, this will probably scroll faster. And it does. Isn't it weird that I'm raising an antenna and it makes things change on the screen? It's so weird. Well, that looks cool. And you can probably parse that. Like you learn what the encoding was, you can parse that. But you don't have to, because dump 1090 does this. You think you could parse that? Oh yeah, that's just a CSV file. And well, it turns out it's actually even easier than parsing it that way. Because I wrote everything in Node. This is a standard format called SBS1, and there's a library in Node that knows how to decode it. It will literally connect to the port and just call an event every single time a message comes in. And so all I have to do is take an object and put it in Redis. So that's what I've done. So let's go back to here. So I have built a silly thing. How am I doing on time? I'm not paying attention to time at all.
You got another 15, 20 minutes?
Okay, cool. I don't want to, make everyone have to stay here till, 3 in the morning. We should be drinking until 3 in the morning. That's how that's supposed to work.
And then tracking aeroplanes, because the police love that.
Yeah, exactly, yeah. So what I've basically done is I have taken that piece of software and I've written some JavaScript code that will pick up that broadcast, shove it into Redis, and then in an event stream. And then I created a little web app which puts it on screen, puts it on a map. So we get a live flight radar of all the aircraft around us. And I actually have, and I'm going to have this going to a cloud database. And one of my coworkers, Simon, is up in Nottingham. And so he's got one of these up and running right now too. And so we should be able to see his data and my data both coming in. I did this in Islington in May, and I picked up aircraft in the channel. And that was just inside of a building. If I actually had this up on the roof on an antenna, you could probably pick up stuff all over the place. But we're going to pick up stuff from further north too. So I'm going to use a version of Redis called Redis Stack to do this. If you've used Redis before, who's used Redis? This is the ad part, by the way. So you've probably used Redis as a cache, and that's probably about it. Most people, usually I say, who's used Redis? And I go, who's used it as a cache? And okay, who's used it as anything else? Does anyone use Redis for anything other than a cache in here? What would you use it as?
Queues.
As a what?
Queues.
For queues. That's almost always the second answer. Either through PubSub or they'll use lists as queues. That's a common solution as well. There's some libraries out there that do that. So, well, Redis has lots of things. And Redis Stack has even more things than Redis does. So Redis Stack is regular old Redis, but we've got added modules to extend it. It includes things to create a JSON data type, so you can actually store a JSON tree in Redis, which is I'm going to use in my demo here. We've added search, so you can create indices to search Redis and find JSON documents that match the criteria you want. We've got probabilistic data structures, which is a big topic in its own. It's another talk that I actually have. But they basically let you trade off, you get orders of magnitude improvements in performance by sacrificing accuracy. So you can get data structures that lie to you. But that can sometimes be useful. So, and we've got time series database in there. And we recently released triggers and functions as well. So you can you can write JavaScript code on Redis. So, which sounds both glorious and horrific at the same time. It's actually very useful. I just wish I could do WebAssembly there instead. So that's the version of Redis I'm going to use. I'm going to be shoving things into event streams in Redis. And so what I've built is several pieces of software. I'm going to call them microservices, but they're really nanoservices, and I'm doing it badly, so don't imitate me. I've got one service called the radio ingester. What it does is it has a software-defined radio. It reads things off the antenna, and shoves it into an event stream, thusly. And the idea is that you can have multiple ones shoving into this event stream at the same time. I've created a radio consumer which reads that event stream and writes out a JSON document that contains the current status of that aircraft. So if I get an updated speed or heading or location, I then update the document to reflect that. And then I build a little API that will search for those using Redis search. We're not going to go into all these details. This is all on GitHub. You can check it out. I wrote a little flight event service, which basically publishes a WebSocket that says, hey, there's this aircraft and it's here, and here, this aircraft and it's here. So all these events basically takes the stream and dumps it down a WebSocket. And I got a little UI that brings it all together. And then a little API gateway to make it work. And I'm going to show you a little bit of code here on how to connect to it. And I'm not going to go over the code too much. I'm going to just kind of go straight to the meat of this. But I'll start with asking who here has used event streaming at all for anything? A few of you? Like you use Kafka. It's basically the same idea. In Redis, we can have an event stream as a key in Redis. So connect to Redis and to SBS1. I just connect to SSB1. I call create client on SBS1. And I give it the host and the port that dump 1090 is publishing on. So that would be localhost 30,003. I can connect to Redis here with this code here. I just call Redis create client to give it whatever my appropriate credentials are that I want. Here I'm just doing the TCP, give it a host name, a port, a password. And then the Redis client, I want to handle any errors. And so I handle errors, and then I call connect. And I'm connected to Redis, I'm connected to SBS1. And then I wait for messages. And this is the call in SBS1 that actually handles messages. You can see why this is easy, because I literally get an object back that just has all the properties that could be there. And then I process those messages. I got to do some transformation on these messages because sometimes the fields are missing, the data is in kind of a wonky format, even by American standards. It's worse than backwards. It's like ISO 8601, but with slashes instead of dashes. I have no idea why. And so you do that. And once I have this in a way that I can shove this on an event stream. And so if you're not familiar with event streams, this is like going to be a 2-minute introduction to the concept. Go read more about it. An event stream is a stack of events with data associated with them. A chronological order. You think of it as like a log file. This happened, and then this happened, and then this happened. And it's like a immutable chronological event of things. And they get assigned an ID, and they have data associated with them, and they just stack up. The IDs in Redis, this is just a timestamp in milliseconds from the beginning of the epoch, and we have a serial number in case you get more than one thing per millisecond. And then you just stack these messages up as they come in. So all I'm doing is every single time I receive a transmission from an aircraft, that's an event. And so I log that event in the event stream. And in Redis, I'm going to skip this because I'm going a little long here. But you can, all the Redis commands in Redis, the talk streams use the xadd. The X commands, there's xadd and xread. And you can do blocking reads, and you can read an amount of them, and there's a whole host of commands, and they're all documented out there. And so, and in code, you just call the same thing in JavaScript code. And all these slides are out in my GitHub repo, so you can go look at the code there. And then this is just the website code. Oh, actually, this is talking about xread here. I mentioned that you can block, so you can sit there on a stream and wait for new data to come in, and so you can do a blocking read with xread. So here we were saying xread block, wait up to 5,000 milliseconds. Here's my stream. The $sign is a special keyword that means wait, look at the end and wait for something new. And then down here, if we add something to that stream, then we get, hey, we read the thing we just added. So that's the idea. And let's skip this one here. This is just an example of how you can code that loop. There we go. This is mostly for reference for y'all later. And then this is how to use a WebSocket for if you don't know how to use a WebSocket. So let's get to the demo because that's what everyone really wants to see, right? Okay, so let's go over here. So I've got dump 1090 is running, We change it to code, and then talks, and then tracking aircraft, and then we got the radio. We'll do the radio adjuster first. And if I do Docker compose up, it should start pulling things from the radio. What did I do wrong here? It's not talking to Redis. Oh, it's because I'm not on a network. What's the Wi-Fi here?
Here, let me give you a tether spot.
What is it? Fund apps?
No, yes.
Dylan's iPhone SE. That sounds like a great network.
Yep.
And I will not put a show password. There we go.
Should be good.
Or you can use this one.
Let's try Dylan's hotspot. Now, every single transponder message off this antenna is going to go through your phone.
So you're now tracking aircraft over central London, and it's my phone that they're going to trace the IP address to.
Modern
Oh, look, I'm not on the internet. Can I borrow someone's phone?
So it should be picking up signals here. Let's go out to let's go look in Redis Insight here. So Redis Insight's a little GUI client to talk to Redis. I've got my tracking aircraft database, which is out in the cloud. I've got that local one, which is local. And if I go out here, we're going to see how fast Dylan's phone is. This is not reassuring. I can convert my demo to do local if I need to. I'll still need your phone for the. That is not connecting.
Yeah, I'm getting 20 megabits, so.
Yeah. The connection is timed out.
It's probably DNS.
Yeah, that could be, yeah.
Normally DNS.
Well, and this is like the URLs in like GCP, Iowa. This is so. Oh, hey, now it's going. So I'm probably going to switch this out to work on my local network. I'm going to stay connected to your phone because I still need to
cool.
maps. And we won't see anything from Nottingham, but we're getting plenty of signals, so we'll be fine. So let's just go ahead and.
Oh, you got a screen.
Refresh now. If I go into radio events, you can see that you should be able to see that there are events happening in here. So here we have, this is some stuff that Simon's done. I don't know if mine are going in here or not. I am going to do this locally though, because I don't think my stuff's getting in here. Maybe W1090 has crashed. Oh yeah. Yeah, we're gonna do local. We'll go back to databases. No demo is ever great unless it fails. So let's go to that local one, which you can see I have a full Bigfoot sightings. That's another talk idea. We'll do that. Do the best Redis command of all time. Anyone know what this command does?
Does it flush all?
Yeah. And see what it responds with? It says, okay. And now if I refresh all 4,586 of my keys, you'll see that my database is now empty. And it didn't even ask, are you sure? Beware. Okay, so I'm going to go over here, and I'm going to go up to here, launch code. And we are going to change my Docker compose to use this one and not this one. And then we're going to do the same thing for here.
Might want to change that pass-through reference on.
What's that?
Might want to change that pass-through reference on.
Yeah, I will. Yeah. Yeah, so don't even think about it internationally. Okay. You too could go and put things in the database that costs me $30 a month. and then it would be full.
And we've seen how
And then I would
difficult
change my password and delete it all.
we've seen how much work it is to remove them, right?
Right, yeah, exactly.
Flush
Not-
them. Okay.
Actually, the fun fact is that there was a fun story. We had someone on our Discord server that was they're like, my data keeps disappearing from my database. It turns out it was exposed to the internet with no password. And someone had people pour scan for these on the internet, and they would go in and flush it all. And we found out because he used the monitor command, which will tell you all the commands that are being run against your database. And he's like, well, this is coming in and it says flush all, but I'm not putting it in. It's like, look at the IP address of the person that's doing it. It's not you. Like, oh, yeah. Security stuff. Okay, so that should work. Let's go ahead and change directory back into ingester. And then Docker goes up again. It's thinking about it. And then I get back, I'm connected to the local database. Okay, so it's working. Here we go. So events are streaming in. Here's is Radio London. That's the timestamp. Okay, so all this data is coming in here. Cool. If I refresh this, see the timestamps are changing. So data is coming into Redis. Let's go ahead and bring up my next tab, new window, guys light, code, talks, tracking aircraft, code, Docker pose. Now what this is going to do is it's going to pick up all the other services. This is going to do the event streaming, or the WebSocket. It's going to start creating JSON documents and everything. So this is running here. And if I go back into Redis Insight now, and I go back to my browser and I hit refresh, we'll see JSON documents for all the aircraft is picking up. So this is at velocity 179, heading 270. It's descending. It's BAW 375Z. Wait, no, wait, I need to say that as Bravo Alpha Whiskey 73. Oh, that's not man.
It's going from Toulouse to Heathrow.
Did you just look it up?
Yeah.
Yeah. And so here's all the information about it. So, and if I refresh this, you'll notice that it's information updates. Now, it will if I wait long enough. I gotta wait for another message. So it is actually feeding this data in and updating it. So this is cool. We got like a real-time flight tracker, but it needs to be a little more visual. Let's go ahead and do that. Go to localhost 8080, and we zoom in a bit. Allow it to get our current location. This is the aircraft it is picking up right now. And if I pull this up, like if I pull this antenna up, we should see more. Yeah, see, it pops up more. Isn't that cool as hell? Right? So yeah, it's just
Yeah, that
cool
gets-
thing. And I went ahead and I've got various APIs here, so I did a little search API. So I can find all the aircraft that are heading north, which is none of them apparently. Or I can do all the ones that are above 10,000 feet. So I created a whole bunch of search options that are in the code that you can explore if you want to. And it does click through to Flyware, so you can find out what this aircraft is. So that is EasyJet, arriving in 33 minutes from it's heading to Bristol. And yeah, so you see we're picking up aircraft fairly far away. I mean, we're not getting anything out of the channel, but it's close. So yeah,
So you see all the ones that are in a little straight line.
those are aligned.
That's all final approach to Heathrow, yeah.
Yep. Yeah, if we click on them, we'll see there. British Air, KLM, and ITY. I don't know what ITY is.
ITY248.
Maybe Italian or something.
I'm guessing Alitalia.
So one fun thing in the implementation here, I tried to create little icons on here and then rotate them to the exact heading using CSS, and it got all janky and weird. And so I just created 16 images. and then I just look at the heading and then I pick the right image. Actually, it wasn't too hard. I was able to just do math and then use the number in the image to pick the right image and everything. So yeah, that's my fun little demo. Kind of cool. That's kind of fun. And if you had a whole bunch of these scattered everywhere, you could feed them all into the same database and get a radar map of all the aircraft in the UK, which would be kind of fun. I don't think this is illegal. Yeah, he got arrested after the talk. It was the best talk ever. So let's go ahead and finish up the slides here. I'm almost done. I just got a couple plugs. I can take questions. Are there any questions? I think people kind of asked them. You had permission to ask during the talk. I didn't tell you that up front. Any questions?
A few, but I'll wait until later.
What? Okay, excellent. That's perfectly fine by me. So if you want to check this out yourself, this is some of the resources I used, and this I've got a PDF of this out on yeah.
Sorry, so technically your solution shows also military planes.
It shows it will show military planes unless they have turned their transponder off.
Yeah, I mean, it
Yeah.
is really something, but flight radar or whatever you demonstrated will not show them, right?
Correct.
I see.
Yeah.
So we experience a spy lesson.
Yeah. there is a website, ADB-S Exchange, and there's another one called the Open Sky Network. ADB-S Exchange is a bunch of people that are doing this, but they're not. It's all like open data. It's sort of the idea, and so they don't honor any requests to block anything. They just say, well, "This is just what I see in the air." And then Open Sky Network has large databases of all the aircraft are out there, so you can actually then take the ICOA ID and say, well, that's a Cessna, or that's a 747, or whatever, and find out what kind of aircraft it is, who owns it, that sort of stuff. And it actually does say the owner is things like U.S. Navy. So it will identify the military craft. So it's not fighter jets usually, it's like cargo carriers, that kind of stuff. But yeah, it's good fun. It's kind of like having another sense. Like you can run this in your house and you're just like watching the aircraft, you're like, this is all around me and I have more information about my situation. It's like gives you situational awareness or something. It's really neat. It's very fun. But yeah, so Redis Stack, you get out. Honestly, the easiest way to get Redis Stack is just Google Redis Stack. That's the easiest way to get it. That's the version of Redis I was using. SDR software, all the versions I talked about there. If you want to go to AIS trackers, these were in the talk as well. The ADSB trackers are FlightAware, ADSB Exchange, and Open Sky Network is another one. And down to 90, the code is out there on GitHub for anyone to knock it out with. At Redis, we have a Discord server where if you have Redis questions, you can come and ask them, and probably I will be the one that answers them. We got free classes at Redis University at redis.com, and if you want to get Redis Stack in the cloud, you can go to redis.com/try-free. So, plugs over. If you want any slides, you can use this QR code, get the slides, and it just goes to the URL. It just goes to the repo. QR code is totally safe. We'll never give you up. Never will let you down. And that's what I got. Thanks a lot.